Hey guys, this video is for pre-cal. This is 9.1. We're onto our second shape of conics, and this is called an ellipse. So visually, I want you to imagine that you grabbed the circle and you kind of squished it a little bit. So think of a football, right? So in the equation for a circle, we had a specific radius that we went side to side and up and down. For an ellipse, the biggest change here is that we're going to have two different radiuses or radii. We're going to have one that goes horizontally and one that goes vertically because they're not going to necessarily be in the same measurement. If they are the same measurement, that would classify it as a circle. When they're different measurements, that's what classifies it as an ellipse, okay? So now what determines, it's as simple as this, what determines whether this is going to stretch out vertically or horizontally is whether the larger number is underneath the x's. So we're going to count A as being our larger number, right? If A is underneath my x, my larger number underneath my x, then it's just going to go longer on my x and shorter on my y. If the bigger number is under the y, then we're going to go bigger on the y's and smaller on the x's, okay? So just take this as you're finding two different radii, okay? Now, just like in the circle, that number, we would do the square root of it to find our distance for the radius. Same thing with these two numbers down here. We need to find the square root of them, and that will determine our distance horizontally underneath the x and vertically underneath the y. Now, I want to pinpoint a few things really quick. The numerators are identical to a circle. The h and k is my center. There's going to be squares. And then these have pluses in between them. That's very important because the next shape we're going to learn has a minus, and it's going to change the way this looks, okay? And the fact that they are always equal to 1, okay? So now a few more details. Let's take a look at this on how to classify these things. Let's talk about what they're called, how to find them numerically. So we said that the center was going to be h comma k. Now, my radius for my x, if it's the A, it's because it was the bigger number, right? Or if it's stretching horizontally, it could be the B. You were just, again, A or B, don't stress it. It's going to be a number, and it's the one underneath the x. My radius for my y is going to be the number that goes underneath the y. Now, if you notice, I kind of color-coded all of my oranges to represent this horizontally stretched ellipse, and then green to represent all the vertically stretched ellipse. You don't have to memorize the details that distinct because, again, the details will be under the x when it stretches on the x and under the y when it stretches for the y. Now, my major vertices are the endpoints on the longest side of my ellipse. So, again, if it's stretched up and down, then it's those endpoints. If it would have stretched horizontally, then it would have been those endpoints. So I use a capital M to represent major vertices, right? So if you just find your center, you're going to then to that x value add up the radius and add down the radius, and then you can find the ordered pairs, okay? If you like to do it without your graph, I have, your setup here with the number depending on what's in the equation. I personally like to sketch the graph. I think it's so much easier to see it with my tallies on my graph, okay? Now, lowercase m stands for minor vertices. Those are just the endpoints on the shorter end, okay? We then have a major axis, which is going to be the length across the longer side. Now, if A was the radius, right, see here of the longer end, if you double that, you'll get what the length of your major axis is. And then same for minor axis with doubling B, whatever the radius was for my shorter end, okay? We have our domain, which is always left to right, regardless of whether it's stretched vertically or horizontally. And then same for range is always bottom to top. Now, what is completely new that you have not seen with a circle is what a foci is, okay? Now, when we're just sketching graphs, this foci is going to seem pretty irrelevant, okay? But when you see how these shapes are used in real life objects, and we'll be doing something at the end of this chapter to see that, the foci has huge implications, okay? Just to give you an idea, something as simple as a satellite, you have that dish, which is parabolic, and then you have the antenna, which has to be perfectly at the foci, or else the satellite dish does not work, okay? But again, we'll talk more about that later. So how to find this foci? This foci is always on the major axis, always on the longer one, okay? Now, it is a distance called C. Right here I put the letter C, and my stars here represent my foci. Now, to find that C, that distance, we have to do the square root of a squared minus b squared, meaning square root of the larger number squared, which is whatever the denominator was, the larger denominator, minus the smaller denominator, okay? Once you get that distance, you are going to add it, right, upward and downward if it's stretched vertically, or you're going to do it horizontally to the x, right? If this is seeming like a lot of information, a lot of letters, watch an example or two. I'm going to have a few for you to even try on your own, and hopefully it makes more sense once you see it in action. Let's take a look at this first example, and little by little, we're going to go upping the ante, making them a little more complicated, all right? So if I look at this first question, I don't see a minus or plus next to those h's, next to the x's and y's, meaning no h and k. So if you don't see any, you can assume that you're centered at the origin. There is no shift. Okay, so far I'm centered at the origin. Now, underneath my x, I have a 9, and underneath my y, I have a 4. So my radius for my x is going to be that square root of 9, so it's going to be 3, which means on my x, I'm going to go 3 to both sides. 1, 2, 3, and then 1, 2, 3. My y, I have a 4, so my radius is going to be square root of that 4, so it's going to be 2. I'm going to go from my center up 2, and then down 2. Okay, so when I draw this, let me get a different color. Do not worry if your images look like your circles look like ellipse and your ellipse look like circles. It just depends on how you drew it, how well you did your tallies that time, okay? So there's my ellipse so far. Let's keep going. My major vertices, my longer ends is going to be these two. So this is going to be a 3, 0 and a negative 3, 0. All right, I'm going to list those here. I always like listing smaller to bigger. Now, minor vertices, my shorter side is these. It only went 2. So now here I have a 0, negative 2, and up here I have a 0, positive 2. I'm going to list those. Now, my major axis, if this is the longer side, I am going to call this my major axis. And if I went 3 to both directions, then double 3, 2 times 3 is going to be 6. So I double my radius for my r, because r happens to be longer, and I get 6. Okay. Now, my minor axis is the length of my shorter side, and if I went 2 in both of those directions, I'm going to double that. Okay. Now, my domain goes from negative 3 to positive 3. And my range goes from negative 2 to positive 2. Now, what I have left is my new information, my foci, okay? So in order to find my foci, I have to find C. C is the square root of a squared minus b squared, which is the bigger denominator minus the smaller denominator, 9 minus 4, which gives me square root of 5. And if I know square root of 4 is 2, the next one up would have been square root of 9 is 3. This has to be equivalent to 2 and a little bit, okay? Now, I tell you that so that you know where to sketch it. That 2 and a little is going to move from my center, okay? So that means if my major axis is on the x and my center was 0, it's going to be added and subtracted to the x value of my center. Does that make sense? And then comma 0. So I would have gone added 2 and a little. I'm going to put a little star. And then subtracted 2 and a little. On some ellipse, guys, the foci could look like it's really close to the end. And on some, it can look like it's really close to the center. Every ellipse is completely different, okay? And you are now done with this problem. For this next example, you can probably tell that it does not look like it is in its right, like standard position, okay? I do not have that equals 1 here. I don't have denominators. I've got some coefficients here. So let me tell you your go-to. Your go-to is to make sure that this right side is equal to 1. And the way you get that every time is by dividing this number over to the other side. Okay, so I'll start you off here. There's a 36 here, so I'm going to divide by 36. If I divide the left side by 36, it's the same thing as dividing each term by 36. And again, this keeps it equivalent. So now on my right side, I have 36 divided by 36 is 1. Now it's starting to look better. Now 4 over 36 can be reduced to 1 over 9. So I've got y squared over 9. And then 9 over 36 can be reduced to 1 over 4. So now we have x squared over 4. Easy enough? Now we can keep on and move on to the next step. It looks a lot like our old question. The numbers are just reversed. So no h and k, so my center is 0, 0. Underneath my r, my radius is 4. Sorry, my number is 4, so my radius is square root of 4. Underneath my y is a 9, so my radius is square root of 9. So on my x's, I'm going to go 2 out. I'm going to draw this one a little more zoomed in. My center is 0, 0. Radius on the x is 2 over to each side. And then on on y, I'm moving 3. Listen to me getting all tongue-tied. Okay, so I'm going to go ahead and draw this ellipse already. I like drawing it at this point. It starts making it easier to see. Okay, so now my major vertices, now my longer side is going vertically. I go 3 up and 3 down. So here I have 0, 3 and 0, -3 as my major vertices. My minor vertices, my smaller side goes horizontally now. So I've got -2, 0 and 2, 0. My major axis, I went longer vertically, so 3 up and 3 down makes 6. My minor axis is horizontally, it's shorter, and I went 2 left and 2 right, which makes 4. My domain goes from -2 to +2. And my range goes from bottom to top, -3 to +3. Now to find my foci, because I know I went longer vertically now, I know my foci will land vertically. So C is the square root of the larger denominator, which cleaned up was 9, minus my smaller denominator. I get the same C as last time, but I do not have the same foci because, again, now it lands on the vertical side. So I'm going to go 1, 2, and a little bit up, and 1, 2, and a little bit down. Okay, those are my foci, which means if my center was 0, 0, my y value is what's going to be added and subtracted, that value of C. And you can leave it just like that, guys. I will give you full credit for that. The day you take an AP test, they will give you full credit for that. In this next example, we're going to up the level of difficulty by adding a new center other than the origin, okay? So we can quickly see that we have these parentheses and numbers new to this style question. So my center is my h, k, remember, opposite the sign, so it's going to be at 3, 1. So I'm going to go 1, 2, 3, and then up 1. And this is now my center. Okay, my radius on my x, I have an 8 underneath my x, so my radius is going to be square root of 8. Off the top of my head, I know that square root of 9 would be 3, so this is probably a number really close to 3. But if you put in your calculator, you do get about 2.8. Okay, so that means on my x, I'm going to go 2, almost 3 over. So this is going to land 1, 2, almost 3 over. And then 1, 2, almost at this third number over. I'm going to draw the dot right before it, okay? So now my y radius, underneath my y I have a 9. Square root of 9 is 3. So I'm going to go 3 up. 1, 2, 3. And then 1, 2, 3. This is negative 2. And this is 4. And this was 6. Almost 6, we'll say. So now I'm going to go ahead and connect those dots, draw my ellipse. And again, depending on how your tallies came out, mine came out a little this time, is how your ellipse is going to look. So now, my major vertices. If you get confused looking at your image, go back to your equation. My larger number is 9, which is underneath the y. So I know mine even looks a little more stretched out here, but bigger number under the y means it should be bigger here. So my major vertice is going to be right here, which is a 3, 4. And this one down here, which is a 3, negative 2. See how I like drawing it on my graph? I think it makes it so much easier. Now, I know we're all kind of questioning, Miss, how are you going to do this 2.8? Like, what number is this? So you could either add 2.8 to 3 to find out what this number is and subtract it here, right? Or I'm going to show you a shortcut, okay? If you end up with decimals, you could even do this with your whole numbers, okay? My major vertices is going to be this x value changes and this x value changes, but notice that my y is always 1. So I can say 3 plus and minus that 2.8, comma, so technically whatever that gives you is that x value of this dot and this dot, comma, my y value, which is 1. That is a shortcut you are allowed to take, and I just listed 2 ordered pairs at once, all right? So now my major axis, remember, was the y's. If I went 3 up and 3 down, you double that, and that's 6. And for my minor axis, I know I went 2.8 and 2.8, so you could either say double 2.8, but if I'm being honest, I'm not satisfied with that because that is an estimation. 2.8 was an estimation. If square root of 8 was more exact, then I would say 2 times square root of 8, right? Because I'm doubling the length of that square root of 8 and square root of 8. I would even suggest for you to put that in this spot instead of putting the 2.8. Because again, 2.8 is an estimation of square root of 8. All right? So now my domain, that furthest left was this 3 minus square root of 8, right? So furthest left is going to be 3 minus square root of 8. And furthest right is going to be 3 plus that square root of 8. So the notation looks a little more complicated, but I have to do less math this way, right? I don't have to figure out what 3 plus square root of 8 was. Now, range should be easy. We had some nice clean numbers. Lowest was negative 2, and highest was 4. My foci is square root of my larger denominator minus my smaller denominator. So now my foci, remember, on my major axis, which was y, is going to go that distance from the center. So up 1 and then down 1. Okay, so see how these happen to look closer to the origin? So now my foci means that my y value from my center changed. So my center's x value stayed as 3, but then went up 1, right? So if I was at 1 and I went up 1, it's now at 2. And there's always two foci. So the second one is 3, and I went down to 0. And you are done with this question. For this next one, it is very similar to the last one we just did. I'm going to encourage you to pause this video, try it on your own like if we were in the class together, and then go ahead and press play and see how much you were able to do on your own. I will warn you, I am trying to trick you a bit. Be very careful as to how that equation is written. Take a look at where I put the x and where I put the y. All right, so hopefully you have paused this video, tried it on your own. Let's look at it together. The trick was that I had written the x value second and the y first. So if you'd like, you can take a moment and rewrite it. You don't have to, but be very careful that you don't mix up this information, okay? So remember, a center, any ordered pair is always my x comma y. So it'd be -2 comma +1. The number underneath my x is 9. Square root of that number is 3. The number underneath my y is 4. Square root of that number is 2. So I went ahead and drew that. My center at -2, 1. I went 3 to the right and to the left on my x's. And because that was the bigger number, that gave me my major vertices. And then my r was my radius for my y was my smaller number 2. So my y went 2 up and 2 down. And that gave me my minor vertices. All right. Now my major axis, we know that my x's were longer and I went 3 to each side. So double 3 is 6. And my minor axis, my shorter was my y's. And on my y's, I went 2 up and 2 down, which gives me a total of 4. My domain goes from -5 to +1. And my range, my lowest, goes from -1 to +3. All we have left now is to find our foci. So we start by solving for c, which is the square root of my larger denominator minus my smaller denominator, which we end up with square root of 5. Okay, I know square root of 5, we said it was approximately 2 and a little. So because my x-axis is my longer axis, I'm going to draw my foci there, and I'm going to go 1, 2, and a little bit, right? And then 1, 2, and a little bit. Now, remember our shortcut for writing the ordered pair for that? We're going to grab our center, and then we're going to add it and subtract it. Because I went sideways, I'm going to add it and subtract it to my x value, okay? So here's my center. I'm literally going to rewrite it, but after I write the x value, I'm going to add and subtract my value of c, and then keep writing the y value. And you are done. Looking at this next example, there are going to be some things that feel familiar and some things that are new, okay? When we learned circles, we also learned that the equation could be written in a general form, but in order to graph it, we had to change it over to standard form, and we would do that rule of completing the square, okay? So the same exact thing is going to happen when we're dealing with ellipse, but there's going to be one small added detail, okay? So I look at this equation, it's very clear, it's in general form. I'm going to start with the same exact steps as circles. I'm going to move that constant over, and then I'm going to combine like terms, my x's with my x's and my y's with my y's, okay? So add the 11. And now I have over here 9x squared. I have a minus 18x, okay? I'm going to draw that blank. And then I have 4y squared plus 16y, and I'm going to draw that other blank. And if I put 2 blanks on the left, I have to put 2 blanks on the right. Now, here is where your added step is. In order to complete the square, the coefficient of the x squared has to be, and the y squared, has to be a 1. So what I'm going to do is I'm going to group these together, and I'm going to factor out the 9 from the x's and the 4 from the y's. So I'm going to say 9 x squared minus 18 divided by 9 would be 2. Leave your blank. Divide out of 4, and I'm going to have y squared plus 16 divided by 4 is 4y. Leave your blank. Equals 11, and keep my blanks. Okay? That's the first step that's different. Now we're going to complete our squares as always. So I know that half of a negative 2 is a negative 1. Negative 1 squared is a positive 1. Okay? Now, I added a positive 1 here, but please remember that that positive 1 is technically being multiplied by that 9. So when I add it to the other side, I have to say 9 times 1. Here's the newness of this, okay? Now here, half of 4 is 2. 2 squared is 4. But when I put it on the right side, remember that 4 is being multiplied by this 4. Okay? And now you are done with everything that is new. The rest keeps on exactly if you've seen it in the previous questions, okay? So let's keep on with that. I know here I'm going to leave that 9. This becomes x. Put the squared on the outside. Half of the middle term is minus 1. Bring down the plus 4. Put my y, put my square on the outside. Half of the middle term would be plus 2. And now I clean this right side, so I have 11 plus 9 plus 16, and this gives me 36. Okay, now this looks like the question we just did a little while ago where I need to get a 1 here. The way I know that this is not a circle and that this is an ellipse is because I have 2 different numbers here. I can even see it back from the beginning. If this would have been a circle, these 2 numbers would have had to have been identical. But because they're different and it's plus, I know that it's an ellipse. So now I'm going to, right, this is 36. I'm going to divide it over. Okay, now we said that 9 over 36 can reduce to 1 over 4. So I'm going to have x minus 1 squared over 4. And then 4 over 36 can reduce to 1 over 9. So I'm going to have y plus 2 squared over 9 equals 1. And now my equation is ready to be graphed. So go ahead and pause and try and graph that one. All right, let's take a look at the answer to this and compare them to your work. My center was at 1, negative 2, drawn right here. Underneath my x, I had a 4, so the radius is square root of that, a 2. So on my x's, I went 2 to the left and 2 to the right. Underneath my y, I had a 9, so the radius is a 3. I went 3 up on the y and 3 down on the y, giving me my major vertices down here of 1, negative 5. And up here of 1, 1. And now my minor vertices, to the left I had negative 1, negative 2, and to the right I had 3, negative 2. My major axis, if I went 3 up and 3 down, double that is 6. My minor axis, if I went 2 to the left and 2 to the right, makes a total of 4. My domain went from this negative 1 all the way over to this positive 3. And my range went from down at negative 5 up to positive 1. Last is my foci. Okay. My center was at 1, negative 2. Since my larger axis is the y, I added and subtracted what I found for c to the y value. And for the c, I found the square root of the larger denominator minus the smaller denominator, which gave me square root of 5.